Very good.
All right. So we're going to be talking about soil classification systems. We're going to give you kind of like overview of two separate ones, but you should note there's a lot of different ways to classify soils, a lot of different systems. So the two we're going to talk about are the Unified Soil Classification System, or the USCS system, and a more like field classification system. The main difference is systems of the USCS system are based off of laboratory tests that will give you very clear information about the property of the soil, whereas field classification systems are more oriented at just kind of getting a general idea of the soil. So we're going to kind of explain generally how these work, because as a general person, a lot of the complicated information in here isn't very useful. And we're going to kind of go to the field description a lot, because as just a person who maybe doesn't have a great understanding of geotechnical information, this can actually be useful to them. And then the other thing is we're going to kind of like work on refining the information after we get this, and like we're going to maybe have some graphics flash up for describing these tables. People can like pause the video if they wanted to and like learn more information about it. Anyways, I'm going to go to this field. So soil classification systems, there are a lot of different systems. The three main ones you're going to hear about are the USDA, or United States Department of Agriculture, the AASHTO system, which is a system designed for transportation officials, and the USCS system, which is the Unified Soil Classification System. We're not going to be talking about the USDA or AASHTO systems, as they're not as commonly used in engineering practice. The AASHTO system is very specifically designed for describing road soils. If you're trying to build a roadway, it's going to give you a very quantitative information about how good it's going to be for a roadway. So we're not going to talk about that too much, because it's a very mathy system and would be very helpful for explaining properties. So the USCS system starts with collecting a sample of soil, and then once you have that sample, the first test you're going to have it undergo is a sieve analysis. So in a sieve analysis, you have a stacked number of sieves with sizes. The sizes are usually graded by number, and that number corresponds to the number of openings in the sieve per square inch. For example, a number 40 sieve is going to have 40 openings per square inch. So as it goes down, you're going to have an amount retained on each layer, and then you can weigh the amount on each layer to determine what percentage of the soil is that size or larger. And if you want to get really fine information on that, you can also undergo what's called the hydrometer analysis, where a piece of equipment called a hydrometer is placed in a sample of water that has the smallest possible chunks that are really hard to measure in a sieve. And then after you undergo that, you can get the information from the very small particles. It's not always necessary, especially when you have a lot of larger soil particles. It's not always done. From these size analysis, you can create what's called a grain size distribution chart, and you're going to get a curve kind of like this. And then from this, based on the size of the sieves, you can determine what percent of the soil each thing is. So generally, it's classified as gravel, sand, and fines. So then from these percentages, you can kind of get an idea of what type of soil it is. Is it a more fine soil? Is it a more coarse soil? That kind of stuff. Then you perform what's called the Atterberg limit tests, which test for the liquid limit and the plastic limit. The liquid limit being the water content at which the soil starts to behave like a liquid, and the plastic limit being the water content at which point the soil starts to exhibit more plastic properties, or becomes more brittle. It's not as pliable anymore. You can take the liquid limit and the plastic limit, and you can subtract the liquid limit from the plastic limit to get the plasticity index. The plasticity index is a quantitative measure of how often the soil has plastic properties. So for a soil that rarely exhibits plastic behavior, you're going to have a small plasticity index. And for a soil that often exhibits plastic behavior, you're going to have a large plasticity index. And from all this information, you can combine that to determine the soil type. Field classification systems, however, are more visual. You're not going to be doing a lot of really complicated tests because you're going to be out in the field. So it's going to be a stuff of what you can see with your eyes, and maybe just dump some water on some soil. So first, you determine what type of stuff you're looking at. So things that are larger than a grapefruit are classified as cobbles and boulders. Things that are about the size between an orange and a pea are classified as gravel. If it's between rock salt and powdered sugar, it's called sand. And anything smaller than powdered sugar is fines. That's kind of really hard to imagine because that's really tiny. But if you think about like clay that you like use maybe in an art class, you really can't see the individual pieces, and that's kind of what we're getting at with fines. So if it's coarse material, The only thing we're going to do from there is determine the shape of it. Is it kind of like more rounded, more angular? You just kind of want to note that. That's kind of the only real property you're going to be collecting there, outside of maybe color and odor. With fines, you can do some slightly more in-depth tests. So one of the first things you can do is a dry strength test. If you take a chunk of those fines, get it wet, then let it dry out, how hard is it to break that just between your fingers? Is it possible to break it between your fingers? Then you can perform a diligency test. Diligency is the property, I did look this up, hold on. Diligency is the property of when you squeeze or apply pressure to a soil, does its volume change. So when you squeeze a really wet soil, to do this test, you get the soil really wet and then you squeeze it and you kind of see how much water comes out of it, like what happens to the soil. If you look at the table that's here, you can kind of see a different description of what a highly diluted versus non-diluted soil is going to do. Then you determine the plasticity of the soil. So this is the same thing as before. You want to see the point at which the soil stops being pliable and it just starts to crumble when you roll it. So you're just rolling it into about a 1/4 inch round diameter little strip. And once it just starts to crumble, you've hit the plastic limit. And then lastly, when you're rolling it, you want to pay attention to how much effort you have to push into it to roll it into those like threads. And then that can classify the toughness. So then from those properties, you can determine the soil symbol. There's 4. ML, CL, MH, and CH. ML being a silt, CL being a lean clay or low plasticity clay, MH being a more elastic soil, and CH being a fat clay or high plasticity clay. Then from all of this information, you can combine it into a written description, which you can then say, this soil is a brown lean clay with trace to fine sand, medium plasticity. It was moist when I found it, and it's represented by the soil symbol CL.